Let us see the next topic, pruning. It is a continuation of decision tree. So there are two types of pruning. One is pre-pruning and another is post-pruning. In case of pre-pruning, we are splitting the node. We are stopping the tree construction early. It is called as pre-pruning. For example, if there are only 5 instances, no need to split because it will not lead to a significant split. So we are stopping the tree construction. So that is pre-pruning. In case of post-pruning, we are splitting the entire dataset into training set and testing set. Train the training set for the decision tree and run the testing set on the decision tree. Suppose if the accuracy is less, then it means that the tree is overfit to the training data set. That is, you are overfitting the training data. That is, it is accurately working well only for the training set but not for the testing set. So, in case of post-pruning, what is the procedure is, we have to remove the node one by one from the tree. Suppose if the accuracy is less, you start removing one by one the node from the tree. Next, measure the performance on the testing set. Suppose if you have removed one node, measure the performance. If the performance is still less, start again removing the node until the accuracy is improved. Until the accuracy is improved, you should start removing the node. Node itself means what? It is a features. You should not start removing the features. So overfitting in the last the chapters, what we have seen, if there are more number of features, over features, it leads to what? Overfit. So what we are doing? We are removing the features. Here it means that we are removing the node. That's all. So node and features are same. So if there is a overfitting, start removing the features. So next is rule extraction from a decision trees. Means we are extracting the rules from the constructed decision tree. There is one rule which will be created for each path from the root to the leaf. Already a tree is constructed. Let me take an X as an age, X2 is as years in job, X5 is as X3 is as a job type. So these are the different attributes for these three nodes. Let me say take here how the rules is constructed. It is very much simple. So rule 1. What is rule 1? How we are constructing the rule 1? Suppose this is what X1, that is age. If age is greater than from 38.5, yes, and concatenation attribute we are taking it as and X2 is greater than 2.5, then your output will be what? 0.8. This is the output attribute, that is a leaf. This leaf holds the class prediction. Similarly, rule 2. So if age is greater than 38.5 and years in job is less than 2.5, then output attribute is what? 0.6. Similarly, rule 3 is if age is greater than 38.5 means it is false. Means if it is false means it goes here. That is age is less than 38.5 comes here. Then X3 is what? Job type. If yes goes, your output will be what? 0.4. Similarly, if here years in job, okay, here I have taken here as A, here as B, as here as C. If job type is what? A, then it goes 0.4. For job type if is B, it is 0.3. If job type is C, then it is what? 0.2. So like this, just rules are extracted. So interpretability is another main advantage of decision trees. Next is learning the rules from the data. How we are learning the rules from the data? So let us take an example, sequential covering algorithm. What is a sequential covering algorithm is? We are learning the rules from the data set which covers all the tuples. Sequentially we are going on learning the rules. So here now in this covering algorithm, how we are learning the rules? We are learning the rules only for positive examples, not for negative examples. The rules are extracted only for positive examples and not for negative examples. It learns only one rule. So here at a time it learns only one rule and repeat this process gradually covering the full set of positive examples. Only one rule you are learning and it covers all the positive examples. Once you learn the rule, okay, those set of tuples or the training examples are removed from the data set. So here all the training examples covered by the rule are removed from the set, training set. One example we call it as a ripper. In this ripper example, so here you are having set of negative examples as positive examples. So here you start learning the rules, that is for only for positive examples, not for the negative examples. So once you learn the rules for the positive examples, so first let me take this rule I'll learn. So that is rule 1 I'll learn. So this set of positive examples are removed. You are only having these two positive examples. So I will be learning the rules for the next step. This one, rule R2. This set of positive examples are removed. And here I learn the positive examples for this. Rule 3 is run. I'll remove the a set of examples related to this. Like this, as you learn the rules for the positive examples, those set of training samples are removed from the data set. This is one of the example, that is a ripper. Thank you.